So we're looking at parallel circuits here. The rules for parallel circuits: the voltage of the battery is going to equal the voltage across each of the single or every resistor. So if you know the voltage across anything, they're all the same. The total current is going to add up, or is going to equal the sum of all the currents. So if I know the current going through resistor 1, 2, however many there are, they all have to add up and equal the total. All right. And then it may say REQ, which stands for equivalent resistance. I use total resistance. They're the same thing. To do that, you're going to do the inverse of everything. So 1 over 12 plus 1 over 24, hit equals in your calculator. It's going to give you a decimal. And then you just hit 1 over whatever that answer is. Then that is the total resistance. All right, so here's our first one. We start them all off the same way. We make a VIR table. How many resistors? There are 2, so we make 1, 2, no more, and then you make a second or last row for the total. If there's 3, you make 3 rows and then a total. Next thing you do, you fill in all given information. All right, first given piece of information I see is the voltage. It's across the battery. That always would go to the total. I see resistor 1 is 12 ohms, and I see resistor 2 is 24 ohms. So unlike series, we could just add the resistors together. That doesn't work. So what we can do is we can find the total resistance. So we can start off by doing that by going 1 over R1 plus 1 over R2. All right, so that would look like 1 divided by 12 plus 1 divided by 24. That equals 0.125. But remember, you have to take the inverse of that. See this little symbol right here? All right, the 1 over that value. So we would then, in our calculators, we're going to just type in 1 over whatever the hell that answer is. Now, if it's a long unround or it's a long chain of numbers, you don't have to write it all down. You can write down a decimal or 2 or 3, but in your calculator, use the whole damn thing, okay, and do 1 divided by that whole thing. So 1 divided by second. Answer if you're using this calculator, which is what we are going to be using on your tests, and this comes out to be 8. So that is your RT. Okay, so that's the first thing we found. Cool. What else can we do? Well, what else can we do? We have, let's look at the rules. Oh, snap, the voltages are the same everywhere. So since we know it's 24 here, guess what? These two also have to be 24. Okay, no math needed for that. That is just kind of knowing and looking at the rule. And now, beautifully done, we have 2 in any single row. When you have 2 variables in any row, we just throw it into Ohm's Law's triangle. So I1, how do we use the triangle? Covering up I, we have V divided by R. So I'm going to have V over R, but I have to use the numbers in the same row. That's why we give it V1 and R1. So we're doing 24 over 12, and we get 2 amps. So you get I2, it'll be V2 over R2, so that'd be 24 over 24, 1 amp. And then we can do the total. VT over RT, 24 over 8, which is 3 amps. So we have 2 amps, 1 amps, and 3 amps. Now, could I have just done this? Couldn't I have just done figured I1 and I2 and gotten 2 and 3, and then used the rule that I just can add the currents? 2 plus 1 would give me 3. Yes, I just wanted to show it both ways. They both work. Excellently done. Or could I have done it in this order? Knowing that the total voltage is 24, all the others are 24, I could have done 24 and 24. I already knew these two. I could have found this guy first, this guy second. Boom, boom, added them together to get 3, and then done 24 divided by 3 to get the total resistance. That works as well, because 24 divided by 3 would have given me 8, which is our total resistance anyway. All right, I just wanted to show that to you guys because you can get multiple pieces. All right, you can sometimes do these ones in multiple steps. So if this was number 1, we've completed number 1. Okay, if we look at 2, All right, so I do want to just show this because I'm going to do some of these out of order. If you see the current in an ammeter, if you see the current before it goes into any resistor, guys, everyone eyes up. If you see the ammeter before it goes into any resistor, that would mean that's the total current. So if you saw it here or here, like at the end, if it's lowercase a, or if you saw it here or here, that's the total. If you see it going down a branch, that is going to tell you that that is what that specific branch is. So in this case, that's IT. This would be I1. This dude would be I2. Okay. So in this problem here, what is the total current? 3. Right? In this one, it's 3. That's the total. So that means when we figure out what these two are, they would have to add up to 3. When I figure what these two are, they're going to have to add up to 4. These two guys, well, I already should know what the total current is because they have to add up. So if I know current in 1 and current in 2, there's no more resistors, I need to know or should know that the total current is going to end up being 3. So in some cases, this is easier. The only reason why it's sometimes irritating is you have to potentially do the inverse with the whole resistor pieces. Okay. All right. So that was 1. That's 2, 3, 4, 5, and 6. So you tell me which other problem would you guys want to do? Which number? 4. All right. So we can do number 4. Number 4. All right. So by looking at this, it's pretty straightforward. There's no hiccups or anything like that. It just has 1, 2, 3, 3 resistors. So, but we already have. It looks like all the resistor values are given. So this one is just pretty much like number 1. It's just going to be an extra resistor. So you sure you want to do 4? Or would you like to try one of the others? Number 4 is done just like number 1. It's just an extra resistor. I want to try one that looks a little bit more, a little different. Okay, let's do 6. I like 6. So I'm going to leave space here. This will be 2 and 3 on the front, 4, 5, and so I'll start my 6 down here at the bottom. All right. So going to make my V, I, and R table. We only have how many resistors? 2. Fill in all the given pieces of information. I know what R1 is, 10 ohms. I know what R2 is, 15 ohms. And is there anything else? This 30 ohms, or this 30 volts, where does that technically go? What position does it go? Good. In V2, because it's the voltage meter reading across this guy here. All right, sweet. That's all the pieces of information that I know. What can I do? Well, knowing the rules, if you know the voltage at any one spot, right here, what's true about them? They're going to be the same everywhere. So that's what I would do first here. Sweet. And now literally I have 1 and 2. So my method, you can do this again. You can do it 2 ways. Find I1 and I2, add them together. You'll have the total. Voltage divided by the current would give you the total resistance. Or I can do 1 over 10 plus 1 over 15 and do the inverse and get that. It's up to you guys. I'll show it with the RT piece. So 1 over 10 plus 1 over 15 is going to equal 1 over whatever the hell that answer comes out to be. 1 divided by 10 plus 1 divided by 15. This comes out to be 0.16 repeating. So I wrote it down as 0.167, but I'm using this whole unrounded piece. So when I type this into my calculator, I'm going to do 1 divided by second answer, and it comes out to be 6. Because if I just did 1 divided by 0.167, it comes out to be like 5.988. So that's why we want to use the whole unrounded thing, because it's most likely it's going to give you the nicest, cleanest number. So I know that that is my RT. All right, I'm actually just going to leave that blank for a second because I wanted to show you that you could do it a separate way. I have 2 of 3 here, so I can find I1 by going V1 over R1. Where did this equation come from? It came from the triangle, guys. Again, the triangle, Ohm's law triangle. V is equal to I times R. I times R would give me V. If I'm looking for I, it would be V divided by R. If I'm looking for R, it would be V divided by I. And so here you go. 30 divided by 10. 3. Right? Wait a second. Something seems fishy. Did I not type that in correctly? I didn't. Let's... Sis. Oh. No? Yeah, no, you're good. You're good. Ah, okay. That's why. Got my own head for a second. Yes, so this comes out to be 3 amps. I2 would be V2 over R2, which would be 30 over 15, 2 amps. So what my brain did for a quick second, I got scared because we figured, I did this method and I figured, oh, that's the total resistance. I was doing this and I was like, wait a minute, that's going to be 3, this is going to be 2, and I was like, why is 5 not equal to 6? I was in 2 different rows. I was in 2 different columns. So there you go. So by adding these 2 together, All right, I can find that the total current comes out to be 5. And then I could use the triangle to find R, V divided by I. RT would be VT divided by IT, or 30 divided by 5, and that's where the 6 comes from. So either way, you could find your total resistance, either method or form you wanted to do. And if I decided that I did this way first and I knew that this was 6, I could have done 30 divided by 6. I figured that to be 5. 30 divided by and figured 2, and I could have then just done 5 minus 2 to get this, or I could have still done the 30 divided by 10 to get that guy. So those were all the pieces of information that you actually determined that were non-given pieces of information. All right, so you guys, your homework will be to complete the rest of the problems. Okay? All right, so I'm going to just do a quick look-see at number 2. All right, so you guys, I would just try to work on this, not look up here until like you're absolutely need to. Don't just try and. I'm just making a piece where I'm doing just 1, 2, 3 of the problems for the videos. REQ is the same thing as RT. Yeah, it's the same thing as RT. Correct. So in this one, I'm looking at number 2. We have 2 resistors, 1, 2, and then we have to then make a row for the totals. Put in the given pieces of information. So I know what R1 is. I know it's 20. I know that R2 is 20. And the only other thing that I do know for sure is that I have a current. So the current before it goes into this, hits this point where the current can actually split. Some can go this way, some can go this way. If it is, the ammeter shows it before here or after this point where it's coming back towards the battery. So like I said, if there's 4 amps here, that would be total. In this problem, because it's going down branch 1, this would be I1. This ammeter is reading it on branch 2, so that would be I2. So in this problem, you have a total current here of 4 amps. So right now, I'm kind of stuck. I don't know exactly what to do or where to go. So looking at my rules, voltages are the same everywhere, can't do that. Current's not the same anywhere, so I can't just say this is 4 and this is 4. I have to figure out the total resistance first. So I would do like the 1 over, right, RT is 1 over R1 plus the 1 over R2. So I would be doing 1 over 20 plus 1 over 20 is going to equal 1 over some number, some decimal. All right, so grab the calculator. 1 divided by 20 plus 1 divided by 20 is equal to 0.1. That's not my answer. You have to remember to take the inverse of that, and that is equal to 10 ohms. So that's your REQ or your RT. Now I have 2 pieces of information to find V. VT is equal to, you look at the triangle. I'm looking for V, cover it up, I times R. So I have IT and RT, so I would do IT times RT, I would do 4 times 10, and I would get 40 volts. So once this is 40 volts, and once I know that, voltages are the same for parallel. And then it's simple. I have everything that I need. I have V1 will be, I'm sorry, we need I1. Haha. Covering up I in the triangle, it's V divided by R. 40 over 20 is 2 amps. And the same thing, since these two are the exact same, all right, and you have the same voltage, it would also be 2. I'm just going to just write the work out, though. And you're left with these were all the pieces of information that you didn't have that you had to figure out. So first thing you had to do was find the total resistance or equivalent. Then you had these two figure that the total voltage is 40 and that voltage are the same along the whole way. And then voltage divided by resistance to get the other two remaining guys. And remember that the currents in parallel need to add up to equal the total. 2 plus 2 is 4. So boom, that does work. Yes.